new chapter, current electricity. Okay, please focus. Our new chapter, current electricity. As compared to electrostatics, current electricity is little bit easy. Okay, current electricity is little bit easy. So, in the current electricity, we will study about the current. Okay, so we know that charge. We know that there is a physical quantity. There is a quantity, a charge, and charge is the property of matter we have discussed, and we have seen in electrostatics due to charge, and that charge was at rest, and due to the charge at rest we have seen electric field is produced, electric force, electric potential, and electric energy. In electrostatics chapter we have charge at rest. So means if the charge is at rest, then we have studied all the things related to this in electrostatics. You can see electro means you can say charge, and statics means at rest. Now what will happen if the charge starts the motion? Now what will happen if the charge suddenly start moving? Like the mass can move, accordingly charge can also move. So as the mass can move, charge can also move. If charge is moving, if charge is in motion, and the motion of the charge, if something is moving, okay, am I audible guys clearly?
Yes,
Please
sir.
tell me. Okay, Matthew, is it
Yes,
okay?
sir. Yeah.
Okay, fine.
Yeah.
Okay, no problem. So okay. Now let's focus. So the motion, if something is moving, the motion means that that body or that thing can move with either with constant velocity or with variable velocity. Two cases are there. If the body or charge is in motion, so charge can move with constant velocity, either constant velocity, and we know that when the velocity is constant, acceleration is zero, because acceleration is change in velocity per unit time. So constant velocity means no change in velocity. That's why we will say acceleration. I am representing acceleration with a. Acceleration is equal to zero. So you can say the motion of charge will be uniform motion. Uniform motion. Uniform motion means when the velocity is constant. And if charge is moving with variable velocity, charge can move with variable velocity also. In this case, the acceleration will not be zero. And this motion is either non-uniform motion, or you can say accelerated motion. accelerated motion of charge, because here charge is in motion. And here, if the charge is moving with the constant velocity, this and all the phenomena related to the charge with constant velocity we will study in this chapter, current, electricity. I will explain each and everything to you. Don't worry about that. And when the charge will be in accelerated motion, you will see this in the electromagnetism. After the current, electricity, we will study electromagnetism. Electro. So see the sequence. See the sequence. First, we have studied charge. We have studied about the charge. We have studied what is charge. See, you can relate it like first we have studied charge at rest. Charge at rest. When the charge is at rest, and we have seen the effect of charge at rest, and the chapter was electrostatics. Now charge is in motion. Now charge in the chapter current, electricity, what will happen? Why we are studying the chapter current, electricity, because we want to know what will happen if the charge will move with a constant velocity, and after that we will see that charge will move with variable velocity. Then we will study the electromagnetism. See the sequence. See the sequence. And very basic thing in this chapter is electric current. Electric current. Electric current, the definition of current, electric current. Simple definition, you can say rate of flow of charge. Rate of flow of charge. Rate of flow of charge means charge flown divided by time, means charge flowing per unit time. Like you can relate it with rate of change of velocity, that is acceleration. Rate of change of displacement, that is velocity. Rate of change of momentum, that is force. Same the case here. Here the rate of flow of charge. Rate means rate is always related with time. So if I will represent the electric current with capital I. Capital I will use the symbol of electric. So electric current I is equal to charge flown, amount of charge flown, you can say, divided by time interval, divided by time, means the amount of charge flowing in amount of time. Okay, so simply current is this. Now we have studied we have two things actually. When we are studying something, we want something for a period of time. For a period of time means a significant amount of time. Okay, and that is known as the average value. Average value. And if we want the things at an instant of time, at a point of time, at a point of time, that those things are instantaneous, like instantaneous velocity. So same the case is here. Same the case is here. Instantaneous current and uh, average current. So for this, I am taking a cylindrical conductor. This is cylindrical conductor, because conductor has the ability to pass the current. Okay, ability to pass the current. We will discuss this in detail. Okay, so now this, suppose this is the cross section area of the cylinder, and this cross section area is constant. That is why this is cylinder. The cross section area is constant. So the cross section area. This is the cross section area, and the charge is flowing through this cross section area I am saying through this cross section area, suppose delta Q amount of charge is passing, delta Q amount of charge is passing from here, also this charge will pass, delta Q. So choose one cross section area at a time. I am choosing this cross section area if I want to find the current. And if you want to find the current, what should you do? Suppose you are here. This, suppose someone is here, this person is here, and this person is watching this, only this cross section area, only this cross section area for a certain period of time. Like you can say for 3 seconds, he or she is watching this cross section area, and he is noted that this amount of charge has flow. So he or she is watching from here at this cross section area and seeing this delta Q amount of charge has flown in delta T time, in delta T time. Okay. So here average current, if I write the average current, I am taking the average because delta T is a fixed amount of time, not an instant of time. Okay. Average current from this cross section. So I will represent average current I like this. And average current is the delta Q. Average current is the delta Q flowing, and in that delta T time. This will be clear when we solve the numericals. So this is the average. And now if someone is asking that you are here and someone is asking from you, calculate the current at t is equal to 1 second, means at a point of time. So if you want to calculate things at a particular point of time, then we have to use the instantaneous value. So instantaneous current is current at an instant of time. And for calculating instantaneous current, we have to use the differentiation. We have to use the differentiation means instantaneous current. I will represent INS. This is instantaneous current. This delta will become dq by dt. Suppose this is the conductor of the length L and of length L, and we have seen in the electrostatic when we take very small length of this conductor, very small length of the conductor, we always use dl. So d means very small. So here charge is very small because time is very small. So this is the instantaneous current. Instantaneous current means current at a point of time. Average current means when someone is asking you the value of current for a certain period of time, definite period of time. Okay. Now unit of current. Unit of current. We know that current is equal to charge. In the simple word, charge flown divided by time. And we can find the unit with the help of formulas. So the unit of charge is coulomb divided by the unit of time, the SI unit. Time can be in minutes, time can be in hour, time can be in second, but we are taking here the SI unit to time in second, and this coulomb per second is known as ampere. And I will represent this ampere with A. And this ampere is the SI unit because this is also the SI unit. SI unit of current. SI unit of current. Now we will decide. We have discussed what is current. After that, what is average current and instantaneous. After that, we have discussed the unit of current. Now we will discuss whether the current is scalar or vector. Whether the current is scalar or vector, please note it down. After that, we will discuss. Please note it down and please ask me to scroll down when you have finished. And remember one thing, when charge is at rest, no current generated. When the charge will be in motion, there will be current generated. When completed, please ask me to scroll down. Nawal and Matthew, I will request you, please try to respond in the class because it is very difficult to teach like this when no It looks like that I
Sir,
am.
can you scroll down?
It looks like sometimes when I teach to the students, it looks like I am teaching to myself. And this is the cylindrical conductor, and this is the cross section area. That shaded region is the cross section area. And Q is the charge. Delta Q is the amount of charge.
Sir, can you scroll?
Nawal, are you writing or not?
Yes, sir.
We have taken here D because we want to find the average current. Oh, sorry, instantaneous current. Instantaneous current for a very small time dt. D. When completed, please let me know.
Done, sir.
Okay. And this is comparatively easy chapter as compared to electrostatics.
You're done, sir.
Okay, fine. Now we will discuss whether the current is scalar, vector, or what is this. We don't know this time the current is scalar or vector. I am not telling. We will discuss. Scalars have only magnitude. We can add these scalars directly. Like charge is scalar, charge is Q, charge is scalar. This is just for explanation. Please don't note this down. Okay. Charge is a scalar quantity, and we can add charge directly. Like I am suppose I am saying this is Q and this is Q1 and Q2. So I can directly write Q1 plus Q2 is equal to Q. Or in the simple words, we can add the charges on a body. Here is plus 2 coulomb charge. Here is, we have done this in Gauss law also. Here is uh, plus 9 coulomb charge if we want to find the total charge. So we don't require, we know there is no need of direction. We simply add the charges like this. 11 coulomb. So charge is the scalar quantity. No need of direction for this. Okay. And the same thing is for you will do for the current. Same thing you will do for the current. Suppose here like this. If 2 ampere current is flowing like in here from here and 3 ampere current is flowing here. So in this direction, if you want to find the current, then you will simply add 5 ampere. So means you should say current is a scalar quantity. But there is a contradiction here. Current has the direction also. Current can flow in this direction, or suppose here is the wire. Here is the wire. Current can flow in this direction and can flow in this direction, in this direction, in this direction. Means current have the direction and direction also, plus current have the magnitude also. So now here is the problem. Current has the direction and magnitude. The definition of vector is, if a quantity is a vector quantity, means it must have magnitude plus direction, plus it must follow the vector laws. It must follow the vector laws. So current I have the direction and have the magnitude, but this is not vector. This is not vector because this current does not follow the vector laws. Current does not follow the vector addition. That is why current is not the vector quantity. Having the direction, having the magnitude does not mean that it is a vector. For the vector laws must be followed, like force is a vector. We will see this. Why current not follows the vector laws? Suppose here is the current of 2 ampere. Here is the current of 3 ampere. And we know that here the value of current will be 5 ampere. We will add. And if I am saying that the angle between these two currents, direction of currents is 60 degree. Direction of current is 60 degree. Then answer is 5 ampere. Now what I have done, I have changed the direction. I have changed the angle. I have changed the angle. 3 ampere is flowing like this now. 2 ampere is flowing like this now, and the angle between these is 90 degree. But this time the current will again be 5 ampere. Means on changing the angle also you are getting the same results. On changing the angle you are getting the same result. This is not true for the force. If two forces are like this, if two forces are like this, suppose here is 2 Newton, here is 3 Newton, and the angle between these forces is 60 degree, then the resultant of this will be something different. Here the resultant will be, you can calculate the the formula of resultant for the vector addition. Matthew and Nawal, anyone. When two vectors are at some angle, what is the formula for resultant? Do you know? Okay, I am telling. The formula of the resultant is one vector square plus another vector square, a square plus b square plus 2ab cos theta if two vectors are like this. Suppose this is vector a, this is vector v, and these two vectors are at angle theta, then resultant will be this. Resultant will be this. So in this case, you can say here the resultant will be different because here theta is different. Now what you have done, you have changed the angle between the forces 2 Newton and 3 Newton force. You have changed the angle. Now here the resultant R2 will be changed because of this theta. But in case of this current, not so. So in actual, the current is a tensor quantity. These types of quantities which does not follow the vector laws are known as tensor quantity. So you can say current is tensor quantity. But tensor quantities is not the part of your syllabus, so you will consider current as a scalar. Consider current as a scalar. Okay, you can directly add the current.
But sir,
Like,
if current is a tensor quantity, how can it be scalar then?
okay, you are right, Matthew, but I am not saying that current is a scalar quantity. I am saying that you should consider current as a scalar because there are the questions like this. There are the questions like this where you will, if you will consider current vectors, how will you solve these questions? There you have to consider the current as a scalar quantity. You are right, but you have to consider current as a scalar quantity. Okay,
Okay, sir.
I am not saying if you don't agree with this statement, if you don't agree with this statement, you can consider tensor also, but for that you have to study the tensors. Okay, tensor is not in your syllabus. Okay, so that's why I am saying, I am not saying current is a scalar quantity. I am saying consider, you can do like this. If four options are given, what is current? If four options are given, option A is scalar, option B is vector, option C is tensor, option D is none of these. This is 100% correct, always, no doubt. But you have to treat current here like scalar. I am not saying this is tensor. No, this is scalar. Have you understood, Matthew?
Yes, sir.
The meaning of my, okay, so please note it down. I'm just removing this. From where? Okay, from here you want. Noted?
Yes.
Nawal?
Yes, sir.
So, Matthew, have you understood why I have written this?
Yes, sir.
In 4 option, tensor will be correct 100%. Now there is a question: if charge q is like this, t square plus 4t plus 5, where q is the charge flowing and t is the time in second and charge in coulomb. We have to calculate number one, current from t is equal to 0 to t is equal to 2 seconds. Second part is we have to find the current from, current at t is equal to 2 seconds. We have to find this. And here charge is varying with time. Equation of charge is given this. And we have to find the current. Answer 1. Here we have to find the value of current for a time, significant amount of time. Means there is a range of time here. So we will calculate here the average current. So because here is certain amount of time, means from 0 to t. Okay, not an instant of time. So we will calculate here I average. I average. I average is delta q by delta t. So you can say delta q means final charge, or you can say charge at t is equal to 2 seconds minus charge at t is equal to 0 divided by t2 minus t1. Means you can say this t final minus t initial, t final minus t initial. And here you can write charge at t is equal to 2, means you have to put the value of 2 here for calculating the charge at time is equal to 2 seconds. Okay, please put the value and tell me the answer. Nawal and Matthew both. Do it. Then So the answer will be 12 ampere.
Answer 6, right?
Oh, sorry. Divided by 2. This will be 6 ampere. Okay. Now all completed.
Yes, sir.
So second part. For the second part, we have to calculate the current at t is equal to 2 seconds. So here they are asking instantaneous current. Instantaneous current at t is equal to 2 seconds. And we have dq by dt and put the value of t in dq by dt equal to 2. So can you solve this? What is the answer, Matthew?
I didn't complete it, sir.
Oh, okay. Uh, Nawal and Matthew, both of you, do you have the idea of differentiation?
Kind of, sir.
Kind of. Okay, please leave this question and listen to me. For both of you, I am asking. Suppose Q is given like this. So, and I want dq by dt. Can you solve, Nawal or Matthew? If you can, then you can, and otherwise I will take, because we need differentiation here. Hmm.
Sir, can you do it?
What?
I said, sir, can you do it? Because I'm kind of
Yeah, of,
stuck.
of course. Of course. I was waiting for the azan. So now what we will do here? So means I have to tell you from the starting. I'm just checking whether you know. So now we will study differentiation. And if you know Nawal, then it is good. If you don't know, then also it is good. So if someone is saying that y is equal to x square, and you have to differentiate y with respect to x. We have to differentiate, means differentiation of y with respect to x. This is x. Differentiation of y with respect to x. So you will write differentiation of y with dy divided by dx. dy divided by dx. So you will write dy dx and you will write this x square. And this dy by dx is a mathematical tool. Differentiation is a mathematical tool. So in simple words, if you want to find the answer, what you should do, this power you should write here. And this is x square, right here x. So answer is 2x. Means decrease 1 from the power. If suppose y is equal to x cube, if you want to find dy by dx, then write 3 here and decrease 1 power. This will become 3x square. If y is equal to x to the power 6, then if you want to find the differentiation of y with respect to x, then write 6 here and decrease 1 power. This will become x to the power 5. Got it? Now, Matthew.
Yes, sir, I got it.
So please solve this question, x to the power 10, and find dy by dx in the same way I have done. And now all you also. If you know, then it's okay. You know it, then it's okay. Otherwise,
So it's
Nawal,
10x raised to minus,
Yes,
10x
sir.
raised to 10, 9, right?
Matthew, please repeat 10
X raised to 9.
9. Nawal, what is your answer? Nawal, what is your answer of this dy by dx?
10x raised to 9.
Very good. Both are correct. So now solve one more question, and after this I will x to the power 1001, and you have to find the dy by dx. And one by one, tell me the answer. First Matthew, and after that Nawal, when completed. You have to do the same thing. You have to do the same thing. Because we will use this integration, this differentiation.
Done, sir.
Okay. So Matthew, tell me the answer.
1001
Yeah.
into x raised to 1000.
Okay. Nawal, now please tell me the answer.
I got the same answer.
Means you guys. One 1000. No, I am changing little bit. If y is written like this, that 5x square. So in this case, if someone is asking differentiate y with respect to x, so what you will do, you will multiply this 2 with 5 and decrease 1 power here. This will become 10x. If y is equal to 19x square, then dy by dx is equal to 19 to the 38 into x. Now I am asking one question from both of you. y is given as 15 x to the power 6 and I want dy by dx. First Nawal and after that Matthew. Don't think this is very easy if you know this. Then
Yes.
Nawal, tell me the answer.
15x raised to 5.
15. Actually, what you should do now, in this types of question, you should multiply this 6 first with
It's 90x raised to 5.
x to the power 5. Okay. Matthew, your answer is same now?
Yeah, so 90 x raised to 5.
Fine. Okay. Suppose y is given 5x square plus 3x. This is given. And I want dy by dx this time. So what you should do, you should distribute the differentiation in this whole equation. Like what you will do first, you will do the thing for this 5 to the 10 and this will become x. And now you will use this plus sign and now you will write here 3 because 3x to the power 1 and 3 into 1 is 3 and x to the power 1 minus 1 will be x to the power 0. Fine. And always remember, if y is constant, if the value of y is constant and if we want to differentiate a constant with any quantity with respect to x, suppose here I want dy by dx, then it will always equal to 0. Like if y is given as 5 and I want dy by dx, it is equal to 0. So now I am giving you one more question. Y is equal to 16x square plus 13. This is x cube. 16x cube, 13x square plus 9x plus 5. Find the value of dy by dx. Both of you, please. We have done the 90% work. Please do the things step by step. Step by step. First differentiate this, after that this, after that this, after that this constant. And this time no need to tell the answer to me. Okay. You can take your time, you can just say I have completed. And you should check your answer. Okay guys, so check your answer. This is 16 and we will multiply this 3 here. This will be 48 x square. This will become 26x. This will become 9 and this will become 0. So our answer is this. Now finally I am changing the variable. Suppose now this time I have taken q is equal to 5t square plus 60 plus 9 and I want dq by dt. I want, earlier we have y, okay, so let's see. Now I am changing here. I am changing q with y, I am changing y with q and x with t. So earlier it was y and in the denominator dy dx here. Now what you should do, you should treat this like you are doing the differentiation with respect to time. So what you will do here, you will multiply this with the same thing, 5 to the 10 and decrease power 1 here. This will become 10t and after that plus sign here 6 and the differentiation of this is 0. And this is no, this is instantaneous current. So guys, my work has been completed. Now I think we should move. Guys, now have you understood little bit about the differentiation?
Yes, sir.
Yes, sir.
Not fully, but this is just a little bit because differentiation is a chapter in 12th class. But this is sufficient for you guys. And Nawal, do you have biology or mathematics?
I have bio.
And Matthew?
Bio.
Okay, very good. So this is enough for you, I think. And if there will be a requirement, I will tell you. So we have to find the current at t is equal to 2 seconds. Current at t is equal to 2 seconds. What I have done here, now see what I want to explain you. What I want to explain you. I have to find the instantaneous current. Now remove all the things. Yes. Now see here. We have to find the instantaneous current, and we have formula of instantaneous current as dq by dt. And what is the value of q? Q is t square plus 40 plus 5. T square plus 40 plus 5. Now we can differentiate easily. Differentiation of t square, this 2 will come here and decrease one power. This will become 2t. And this 40, what about 40? The differentiation of 40 with respect to is 4 and differentiation of this is 0. So we have got dq by dt. And we have to put t equal to 2 seconds here. Here you should put t equal to 2 seconds. Instead of t, you should put 2. So what is the answer? 8 ampere. So this is the instantaneous current. So in this way, you can solve the questions. Means you just for solving these kinds of questions, you just have to know the basics of basics of differentiation. And guys, what about the integration? Okay, fine. So now I am giving you one question and please solve that question for me. Q is given as 5t square plus 6t cube. Q is given and this is the charge. Okay, this is the charge is given like this, and you have to find current at t equal to 1 second. Guys, please solve this. Current at t equal to 1 second and take your time. Completed. Now please check your answer. I am solving. We have to find current at t equal to 1 second. Means we have to find the instantaneous current. And we have formula dq by dt. And we have q is equal to this. So we will differentiate this. Multiply this with this. This will 5 to the 10 and this will become t. And after that plus sign, you will multiply 3 with 6. This will be 18 and t square. Now put here t is equal to 1. The answer, we will get the answer 10 plus 18. This will become 28 ampere. Okay, guys. So and only these kinds of question you will get in your examination. So Nawal and Matthew, do you know integration?
No, sir.
No.
Okay, very good, no problem. So you don't know the integration. Okay, but now you knew you knew how to differentiate. Now you
Yes,
know.
sir.
And please revise this 1 or 2 times. You will do the questions. Okay, we will. I will tell you the integration maybe in the next class. So now we have find the magnitude and direction of current. Sorry, magnitude of current, and current is a tensor quantity, and you should consider current as a scalar quantity. And now we will talk about the direction of current. We will talk about the direction of current. Direction of current. About the direction of current or whatever I am going to tell you, this is not saying I am not saying this. This has given by the scientists. Okay, I am not saying this from myself. They have done the experiment and find direction of current is same as that of motion of positive charge. From now, you will take the direction of current in the direction of motion, in the direction in which the positive charge is moving. Suppose here a positive charge and this positive charge is going in this direction, then the direction of current will be also in this direction. Means the direction of current is same as that of motion of charge. East, west, north and south. Charge is moving in this direction, positive charge is moving in this direction. You will take the direction of current in east. Okay. If negative charge, here is a negative charge and this negative charge is moving in this direction. So please remember, you will take the direction of current in the opposite direction of motion of charge. Like east, west, north, south. Charge is negative charge is moving in this direction. You will take towards east. Negative charge is moving towards east. Then you will take the direction of current towards west. You can say the direction of current is opposite to the motion of negative charge. You can also say direction of current is opposite to the motion of charge. Graph of charge Q versus time. Graph of charge Q versus time. If this is the y-axis, if this is the x-axis, the graph of current and time will be like this. Means this, the graph will be a straight line passing from origin. A straight line passing from origin. Why the graph of current? If I am taking charge along this axis and time along this axis, then the graph is like this. Why the graph is like this? Because we know that I is equal to charge upon time, and I can write Q is equal to I into T, and we have to move now in the 11th class straight line chapter. Do you have any idea about y is equal to mx? This is the equation of straight line. Equation of a straight line. Passing from origin. Passing from origin. So you want to draw the, I will explain you. So if this is y-axis and this is x-axis, and a straight line is passing from origin like this, then the equation of this line, if this line is making an angle theta, this is line, is y is equal to mx, and here m is the slope. M is the slope, and this slope is given by tan theta. This is math. The slope is given by tan theta. So, and now you can compare q is equal to it. Here q is equal to I into t, and y is equal to mx. So on y-axis there is q, on x-axis there is t here. So what is the slope of this I versus t? From here you can compare equation 1 and this is equation 2. By comparing equation 1 and 1 and 2, you will get the value of slope as current. If you want to find slope is also tan theta of this, okay, slope is also the tan theta of this, but it will also be equal to I, and for I you can write q by t. Okay, note it down. Actually, for the study of physics, you should know basic maths. Not very advanced math, but you should know at least basics of math, like equation of a straight line, basics of differentiation, basics of integration, about the what is triangle, about the triangles, how to find the area of triangle. That is why you have studied the mathematics in the 10th class.
So can you scroll down?
So, okay, please write down. So the graph of charge versus time, and time is t, is a straight line. And this on the y-axis, I am taking charge. On x-axis, I am taking
Done, sir.
Note this also. And remember, this is origin. So note this also. After that, we will solve one question and that's all. Slope is equal to tan theta. Slope of a line, like you can see here. Here is a pen. Here is a pen. And what is the meaning of slope? This is suppose this is. Please understand this. This is a straight line, and suppose this straight line is making an angle theta with this plane. See here. This is the horizontal, and this line is making an angle theta. And slope is this. Means the tilt, how much the line is tilted like this. Okay. When you will increase the theta, slope will increase. Slope of the line is like this. When you decrease the theta, slope will decrease. So slope of the lines mean how much the line is aligned towards the x-axis, you can say. Slope of the line. And slope of the line is calculated with the help of tan theta. This has been done. We also calculate the slope like in 10th class. If you remember, we have Ohm's law. We have Ohm's law, and there we draw a graph of potential and current, and there we get a constant in the slope of voltage versus current graph as a resistance. And the resistance is the slope of the graph. I have done the experiment also in my school. Okay, so guys, have you done the experiment of Ohm's law in your lab?
Yes, sir.
Yes, sir.
Very good. So means uh, you should have some idea of slope. I cannot tell each and everything in detail because we have to complete the syllabus also. If I am telling you the slope, so I am only just telling you the things which are required. Okay, so this is the last question of this class. An electron revolves around the nucleus around the nucleus. The spelling of nucleus is not correct. Around the nucleus with frequency f. Calculate current produced. Current produced. So now please see on the screen carefully. I am solving it. And consider this as circle. This is the circle. Why I am drawing this? We know that the there is a atom. In an atom, around the nucleus, electron revolves. Electron revolves. Here is the electron, and this electron revolves around the nucleus. This is nucleus. Electron revolves around the nucleus, okay, in an atom. So here electron revolves around the nucleus and electron is revolving around the nucleus. And frequency is given. Frequency is given. Frequency is the number of revolution per second, you can say. So one thing you should remember here: time period. Time period is the time taken by this electron. Time taken by this electron to complete one revolution. Means electron now is here. It is moving like this, like this, like this, like this, and after a time, the electron is here. That time is known as time period. Time period. A time period is the time, and time period is 1 upon frequency. This is time period is 1 upon frequency. Okay. And frequency is given as f. So I am representing time period with t and frequency with f. So I can write f is equal to 1 by t. F is equal to 1 by t, or t is equal to 1 by t. And we know that current, here the current will be produced. Why the current will be produced here? Because charge is in motion. I have told you charge is in the motion, so the current is produced. And we know that the current is charge flowing divided by time. So here we will take charge. Charge on electron is, what is the charge on electron? I am taking minus E. So charge on electron is minus 1 point. What is the value? 1.6, na? Coulomb. 1.9 or 1.6?
1.6.
1.6 is to 10 to the power 90, na? Okay. So charge is minus E, and time is time period. You will take the time period, and you know that 1 upon time period is equal to frequency. So this will be your answer. So I is equal to minus. So this minus sign saying that if electron is moving in this direction, then the direction of current will be in this direction. So please note it down. Okay. So time period is equal to 1 upon frequency. So these kinds of questions you can get in examination. Current is equal to charge. You have to take the value of charge on electron. For the time, you have to take the time period, and time period is 1 upon frequency. So this negative sign shows that the direction of current is opposite to that of motion of electron. If electron is moving clockwise, then If electron is moving in anti-clockwise, then direction of current is clockwise. Completed?
Yes.
Nawal?
Yes, sir.
And do you have any doubts in this lecture? Yes or no?
No,
In this,
sir.
and Nawal,
Yes, sir.
what is your doubt? Nawal, I am asking what is your doubt?
Then
What?
there is no doubt.
No doubt, na?
Yes.
Yeah.